Okay, next we're going to look at double angle formulas. So double angle formulas are once again among the set of formulas that you will encounter a lot. Probably most commonly this first one, sine of 2 theta equals 2 sine of theta cosine theta. That comes up a lot. But so do the cosine of 2 theta ones. There are 3 of them because cosine of 2 theta is equal to cosine squared minus sine squared. But then you can use a Pythagorean substitution. So let's say you said, I'm going to get rid of cosine squared and use 1 minus sine squared for that instead. Then you would have 1 minus 2 sine squared. Or say you substituted out the sine squared for 1 minus cosine squared. Then you would have 2 cosine squared minus 1. So again, if you just memorize the first one and know how to do the substitutions, you can get the other two. I rarely, I think if ever, use the tangent of 2 theta in calculus, maybe once in a blue moon. So you don't have to memorize that one. I would not give you something on a test without a without a note card for the tangent of 2 theta. But there it is. That's what the tangent of 2 theta looks like. So in order to use these formulas, you're basically going to do the triangle. They're going to ask you questions like, for example, let's look at an example first. So they're going to give you some information. Tangent of theta is this, theta is in this quadrant, and then ask you to find the sine, the cosine, or the tangent of the double angle. So again, if you're looking at the formula itself, you need the sine or the cosine of the original angle, pretty much for all of these, maybe a tangent for this. So you'll go ahead and draw the picture, draw the triangle, and then just fill in the values you need. Trigonometry ends up being kind of all the same process of drawing the triangle, filling it in, if you're doing it that way, which is another reason why I really appreciate using triangles over the unit circle, because everything is almost the same process. So let's go ahead and do this first one. We have an angle in quadrant 2. Let's see if I can figure out where quadrant 2 is today. Pretty sure it's there. So there's my reference angle. I'll draw my triangle, and now I'm aware of the tangent, which is opposite over adjacent. It's negative because that 4 is in that negative x direction, but the y, the 3 is positive. And so if you use your Pythagorean theorem, you might have memorized by now that if the two legs are 3 and 4, the hypotenuse is 5. But you could prove that to yourself using the quadratic or the Pythagorean theorem. So now we're going to find sine of 2 theta. And I'm just going to write down what that's equal to. It's the sine 2 times the sine of theta times the cosine of theta. So that would be 2 times. The sine here would be opposite over hypotenuse. And the cosine would be adjacent over hypotenuse. So I just multiply those all together, and I end up with negative 24 over 25. The cosine of 2 theta, I have 3 choices of what I want to use. I could use any of these 3 formulas. I'm going to choose to use the first one here because since the cosine and sine are both going to be fractions, if I use cosine squared minus sine squared, they will have a common denominator already. So I already identified up here what the cosine and the sine were. So I need to do cosine squared minus sine squared. That'll be over 25, and it looks like I'll have 16 minus 9, which is 7. And last but not least, I'm going to do a really clever trick here. Since it wants me to find tangent of 2 theta, I could go through that formula, or I could just realize that the tangent is the sine over the cosine. Since I've already found those 2 things, this would be a much faster way to do it. So that would be negative 24 over 25 divided by, so I'll do times the reciprocal of 7/25, which would be 25/7. And now I end up with -24/7. So that is going to follow my mantra of think smarter, not harder. If you already know the sine and the cosine, just divide them to get the tangent. Okay, and then the second example that I have for a double angle, and this is another situation you are going to use the double angles to do some simplifying. So I have an expression here, and I want to simplify it, similar to what we did with some of the other identities. Now, I notice on the bottom, I just have cosine minus sine. There's nothing I can do to simplify that. So I must have to do something with this cosine of 2 theta. I must have to use one of those 3 equations that it's or expressions it's equal to substitute in that will somehow simplify here. So keeping in mind that my denominator is a cosine minus sine, which of these 3 things do you think would be most helpful? I'm hoping you're seeing the cosine squared minus sine squared, which could be factored using a difference of squares. So what we're going to do in the first step is just do the substitution, because we know that cosine of 2 theta is equal to cosine squared minus sine squared. You cannot cancel anything at this step. Everything is a term. So I would need to factor and now I can cancel the entire factor, and I'm left with just cosine theta plus sine theta. Okay, so yet another example of doing that simplification using identities and substitutions. All right, last but not least, I'm just going to mention in this video that there are these things called half angle formulas. I put them here because you do need to be aware of them. And we are not going to use these identities in this class because the places that they arise in calculus are places where you're going to be able to just use them then, and they're kind of tedious. We have enough identities as it is, but just to be aware of the fact that if you were trying to find the sine of half of an angle, then you could use this formula where you do 1 minus cosine of the angle divided by 2, square root it, and then the plus or minus has to do with which quadrant it would land in. So if theta was in quadrant 2, where would half of that theta land? And then that would identify whether you would use the plus or the minus. Okay. So like I said, there are these formulas. We're not going to mess with them much in this class, but when you need them, and the place you really need them is Calc 2, you'll get a quick review on using them, so you'll be in good shape then.